Audio Jungle. Audio Jungle.
Hello everyone, myself Naren Singh Maurya. So guys, today we'll solve rocket propulsion problem, and here we have gate 2022, problem number 47. So a rocket operates at an absolute chamber pressure of 20 bar to produce thrust of F1. F1. The hot exhaust is optimally expanded. Okay, optimally expanded to 1 bar absolute pressure using convergent divergent nozzle with exit to throat area A by 80 is 3.5 and thrust coefficient is CF1 1.42. It is given. The same rocket when operated at an absolute chamber pressure of 50 bar, okay, produces thrust F2 and thrust coefficient CF2. Which of the following statements is R means more than one option also correct? R correct. Okay. Option F2 by F1 2.5, F2 by F1 greater than 2.5, CF2 by CF1 1, CF2 by CF1 is greater than. Here it is given like statements. Huh? So this is the MSQ, multiple select question, MSQ, multiple select question. Okay. So more than one option can be correct. All right. Now, so we'll try to solve this problem. So here, rocket, they have given the condition and the same rocket here it is for two different condition. The same rocket is what operating. This is case one, and this is what case two. Okay. In this case one, that here we have we just say this is the propellant. Obviously, here we have a propellant. No? All right. And obviously propellant will be burning, so combustion chamber pressure, and obviously that combustion chamber pressure will be total pressure and it will be denoted by PC, and because this is case 1, so PC1 I will say that PC1 they have given to you how much, 20 bar. Check, 20 bar pressure they have given. Similarly here, second case total pressure is also given, but this is the second case, so I must write PC2 how much it is given. Check, it is given 50 bar. Okay, this is 50 bar. Next, for the same rocket, because this case is what different 1 and 2, but rocket is what same. So hence A by 80. A by 80 is nothing but exit area to throat area. Okay, exit to throat area is given 3.5 because they have said convergent divergent. So here, this is the throat. This is the throat, and this is what the exit. Both places. This is the throat. Okay. So for this throat, and this is the exit. All right. And for case 1 they have given thrust is what, F1, and CF1 is the thrust coefficient. I will tell you what is CF1. So that two value they have given. F1 is a known. Hot exhaust is optimally expanded to 1 bar. Okay, rocket 1. So it is optimally expanded. Optimally expanded means PE is equal to PA. This is the optimally expanded case. optimally expansion or fully expansion. Okay, that case is different: under expansion, over expansion, or fully expansion. Okay, so this is the fully expansion case. So fully expansion case is what? PE is equal to PA, and this is the case one. So you just say PE1, and obviously here thrust will be F1 and thrust coefficient will be CF1, and that value also they have given to you. How much? 1.4. Mathematically, what is the CF1? I will tell you. And similarly here also, you will have a thrust F2, will have a thrust F2, and CF2 will be the thrust coefficient for that too. Okay. Now they are asking the ratio. They are asking the ratio. What will be the F2 by F1? F2 by F1. Okay. Number one. Number two, CF2 by CF1, right? Check. CF2 by CF. We need to calculate this value. Okay. So hope you understood what is the F1, F2. So F1 and F2 both are thrust for the case 1 and case 2 rockets. CF1 and CF2 are the thrust coefficient for both cases. All right. So now how to solve? See, this second case they have said the same rocket when operated at an absolute chamber pressure of 50 bar produces thrust. So, but for first rocket they have clearly mentioned it is optimally expanded. Okay, so the same rocket they are using, but now chamber pressure is what changed, because first rocket chamber pressure was given 20 bar, but it is optimally expanded case. So, okay, so similarly for second rocket also will be operated optimally expanded case, but because of changing of the chamber pressure, exit pressure will be changed. Okay, because here it is clearly, see, exhaust is optimally expanded, so exit pressure is what clearly it is mentioned 1 bar. This value they have given, check, this value they have given 1 bar. Okay, so if I say, okay, I will go with the case one. So optimally expanded, hence PEA PE1 is equal to PA. This is the optimally expanded case, and this value they have given 1 bar. So what will be the pressure ratio? Pressure ratio for optimally expanded. So total pressure in combustion chamber, which is nothing but P naught by PE1, that will also can written P naught is nothing but chamber pressure, PC divided by PE1 is nothing but PA. You can write that because it is optimally expanded and that ratio is given 1 bar. Okay, so basically if you calculate this ratio, so I must say this ratio is nothing but R, and this is the pressure ratio, so I must say RP1, and this RP1 is nothing but total pressure in combustion chamber divided by exit pressure, and this is nothing but 20 bar divided by 1 bar, which is nothing but 20. Okay, this I must say this is the pressure ratio. Okay, I just say this is R. So because this is the case 1, so I am saying RP1. Okay, similarly case 2. Okay, because same rocket, so obviously this pressure ratio must be same. RP1 is equal to RP2. Okay, because it is optimally expanded rocket, so RP1 by RP2. For second case, what will be the RP2? It will be the P naught 2. Okay, this is the case 1, so P naught 1, PC1, P naught by PE1, and this is the value. So P naught 2 divided by, what is the pressure ratio? You are writing for optimally expanded, it is PE2 is equal to, what is the RP1 you have now? 20. Okay, because see, RP1 is equal to RP2 because both rockets are same. So what is the PE2? Exit will be P naught 2 divided by 20, or P02 is nothing but PC2, chamber pressure for second rocket will be 20. What is the chamber pressure for second rocket? Check. It is nothing but 50 bar. So I must write 50 divided by 20. How much? 2.5. This is the pressure ratio. Okay. This is the pressure ratio. PC2, this is the PE2 value. Basically, exit pressure PE2. This is the PE2. Okay. This is 2.5 bar. Here we have a pressure ratio. With the help of this pressure ratio, you can calculate PE2. PE, this is the exit pressure for second rocket. Exit pressure or rocket. Second case. Okay. How much it is? It is nothing but 2.5 bar. Hope you understood. Now, if you want to calculate this ratio, F2 by F1 and CF2 by CF1, so what is the CF1 and what is the CF2? That is the thrust coefficient. But mathematically, how to obtain this CF1 and CF2? I mean, how to obtain that thrust coefficient? So for that, we'll write the formula, very basic formula. We know because we have a nozzle which is nothing but convergent divergent nozzle. Okay? This is the rocket, and this is the basically nozzle convergent divergent, and here we have a this is the rocket portion. Okay, so here this area is nothing but throat area, and obviously we have the exit here. Okay, this is the exit for the rocket. All right. Now, if I will write mass flow rate through this nozzle, because this is the convergent divergent nozzle, CD nozzle. So, non-dimensional mass flow rate. Okay. If I say from this, what is the thrust? So, basically, exit pressure is nothing but PE. Okay. Exit velocity is nothing but VE, and exit area is nothing but AE. So, what is the thrust? One by one, I will write thrust is nothing but F, which is nothing but momentum thrust plus pressure thrust. Yes or no? Momentum thrust is what? Mass flow rate. Just say mass flow rate is nothing but m dot. So m dot mass flow rate into velocity plus pressure thrust is nothing but exit area into PE minus PA. If atmospheric pressure is nothing but PA here, that surrounding pressure or atmospheric pressure is nothing but PA, ambient pressure. What is PA? Ambient pressure. Okay. So finally, you got the formula. Thrust is nothing but m dot VE plus AE PE minus PA. I must say this is equation number 1. All right. For the same CD nozzle, because it is the choked nozzle, clearly they have mentioned optimally expanded means basically that PE is equal to PA, which is the choked condition also. So non-dimensional mass flow rate. Okay. If you write that, and that too for the choked nozzle, and this is the choked condition. Why? Because it is optimally expanded condition, fully expansion. Okay, so for choked nozzle, what is the mass flow rate? Non-dimensional form, m dot divided by throat area. Okay, chamber pressure, you just say this is the chamber, so chamber pressure is T naught, and chamber pressure is nothing but P naught, total pressure and total temperature. M dot P naught divided by P naught, this is the formula, Very generic formula for the non-dimensional mass flow rate. Okay, I hope you all know this 2 upon gamma plus 1 whole power gamma plus 1 divided by gamma 1. This is the value of the mass flow rate, and this mass flow rate is what basically choked nozzle. Okay, where Mach number you are considering here, this is the choked, so Mach number you are considering 1. So that time whatever the mass flow rate you will have, that will be the maximum mass flow rate. Okay, up to here it is clear. Mass flow rate you got for non-dimensional mass flow rate for the choked nozzle. Now this you can write, because if you check here, this mass flow rate you can write P naught into ATH. What is this value? You can write, this is nothing but, because this is the root, so you can take inside the root, and temperature will go this side. So this temperature will be 1 upon root of T naught, and here this is the root. Inside root this R gamma also you can write. So this side, this R by gamma will be gamma by R. It will be reversed. So take it, and this is 2 upon gamma plus 1 to whole power gamma plus 1 divided by gamma minus 1. This is equation number 2. All right. Now, why I am writing in this format, I will tell you. So you have thrust. What is the thrust you have? M dot VE plus AE PE minus PA. This is the thrust is what force. You just write this thrust in non-dimensional form. What is the non-dimensional form? You just non-dimensionalize this. So thrust is the force, obviously. So force equivalent value you have to take and you have to divide it. Okay. So this is the thrust F. If you divide by mass, like pressure into area, because pressure into area will be the force. So force by force will become non-dimensional form. What is the pressure? Chamber pressure P naught. What is the area? Throat area P naught ATH. You can write. So this is the non-dimensional form now. You write it M dot VE divided by P naught ATH plus AE divided by P naught ATH, in bracket you can write PE minus PA. Okay. This value, okay, called CF, called thrust coefficient. Hope you understood. Thrust coefficient. It becomes coefficient because it becomes non-dimensional form now. Okay. So what is the CF? CF is M dot divided by P naught ATH. What is the M dot P naught by ATH? You understood why I have written this M dot by P naught ATH in this format? Because I need to use this. Huh? So now M dot by P naught ATH, that is nothing but 1 upon root T naught. So I will write here. So VE will be as it is, divide by root of T naught. Okay. And directly we'll write the root part. What is the root value? Check. Root value. Check. Wait. Just hold on. So basically here this problem is Just hold on. Okay. So just wait. Yes. So what is the root? It is gamma by r. It is gamma by r upon 2 upon gamma plus 1 to whole power gamma plus 1 by minus and plus a by p naught ath in bracket p minus pa. So hope you understood what is the value of cf. Yes or no? Now case 1, this is the cf value. So case 1, what is case 1? Optimally expanded, which means pe by pe is equal to pa. That's the mean of it. Now if you apply in this equation number 3, okay, okay, so P is equal to PA, that means you will have only CF is 1 will be CF, and that value will, because this is case 1, so I have written CF1, then you will have only VE divided by, okay, root T naught in root gamma upon R 2 upon gamma plus 1 to gamma plus 1 by gamma minus 1, because this second part will be 0. So because PE is equal to PA, so second part will be 0. And this CF1, I think they have given to you also. What is the CF1 they have given? Check. 1.42. So this value they have given 1.42. Now case 2. We'll write here. Case 2. What is case 2? CF2. CF2 is equal to, if you check the value, okay, what the formula you have? You have VE by root T naught in bracket, it is gamma upon R 2 upon gamma plus 1 to whole power gamma plus 1 divided by gamma minus 1 plus AE PE minus PA. Check, this value is nothing but what? Check the previous. This value is nothing but 1.42. This is 1.42. Yes or no? So basically CF2 you have now 1.42 plus AE, and obviously because you are writing second case, so this value will be PE2. Yes or no? This value will be PE2. All right. And if you check here, this is PE2 minus PA, AE, okay, P naught by ATH. This value also need to write here. We have P naught to ATH. This value. Yes or no? So I can write AE by ATH, okay, PE2 minus PA divide by P naught. Okay, I can write this. Now this is what, 1.42 plus what is AE by ATH? They have given to us AE by ATH. How much they have given? Check in the problem. 3.5. 3.5 they have given in the problem. 3.5. Okay. In bracket PE2 you have calculated 2.5 bar. Yes or no? 2.5 bar you have calculated, minus what is the atmospheric pressure? It is 1 bar. Bar means 10 to the power 5. Okay. Divide by P naught 2. What is P naught 2? They have given how much? I think they have given 50 bar. Let me check once. 50 bar they have given. P naught 2. So 50 bar. 15 to 10 for 5. Now what is the CF2? CF2 is 1.42, okay, plus 3.5, okay, in bracket 2.5 minus 1, 1.5, divide by 50. 10 to the power 5, 10 to the power 5 cancel out. How much weight? Let me calculate. 3.5 into 1.5 divide by 50 plus 1.42. This is 1.525. So C up to by CF1. Check 1.525. What is the CF1? They have given 1.42. This is the CF1, yes or no? So if you solve this, divide by 1.42, it will be 1.073. This is the CF2 by CF1. What another value we need to calculate? F2 by F1. So next value we need to calculate F2 by F1. So here you have seen what is the CF? It was F divided by, check, you only have written, right? See, what is the CF you have written? Check here. This is nothing but F divided by P naught ATH. F divided by P naught ATH. So what is the F? F is nothing but CF P naught ATH. What is the F1 then? CF1 P naught 1 throat area. Throat area for the same rocket must be same. What is the F2 then? P naught 2 ATH. What is F2 by F1? It is CF2 by CF1 P naught 2 by P naught 1, and obviously ATH by ATH cancel out. This one. So overall I can say F2 by F1 is nothing but CF2. Just now CF2 you have calculated, CF2 by CF1. It is 1.073. 1.073. What is P naught 2? You know, it is 50 bar they have given. And what is the P naught 1? Total pressure for case 1 rocket. Check chamber pressure. I think it is 20 bar. Let me check. 20 bar. Here. 20 bar. How much it is? Wait. Into, I will write 50. Okay. Divide by 20. So it is 2.68. So you got F2 by F1 is equal to 2.68, and CF2 by CF1 you got how much? 1.07. So this two value you have now. Yes or no? Now we'll go for option. Check F2 by F1 2.68. Need to remember this, okay? F2 by F1 what you got? 2.68. What is CF2 by CF1 you got? It is nothing but CF2 by CF1. It is 1.073. Now check F2 by F1 2.5. No, it is 2.68. Greater than 2.5. Yes, 2.68 is greater than 2.5. CF2 by CF1. No, this is wrong. This is wrong. CF2 by CF1 is greater than 1. Yes, this is greater than 1. So what is the correct answer? This and this. Your answer is nothing but D and D. Huh? This is your correct answer. Answer. Yes or no? Hope you understood. This was simple problem. I had taken so much time. Why? Because I had gone very slow to explain each and every step. You can finish this problem earliest. Okay. So your answer is nothing but B and D. This is greater than 1. And this is obviously greater than 2.5. This is your answer. So keep doing hard work. Thank you. Thank you all.